Hi students, the next chapter from organic chemistry, haloalkanes, haloarenes. This chapter carries 4 marks. They may give one short answer question which carries 4 marks or two very short answer questions, each one 2 marks, total 4 marks. So the weightage of this chapter is 4 marks. So in this chapter, we have 4 very short answer questions, very important, which are asking repeatedly, and 2 4 marks questions. Hope we learn these 3 questions. That is, we learn that 2 2 marks questions as one question, that 4 questions, and 2 4 mark questions also. Total 3. These 3 questions you must and should learn, right? Let's go to that first. Very short answers. So in that first one, ambident nucleophile. I think everybody has listened. What is this nucleophile? Right? Nucleophile means the chemical species which is containing more number of electrons, which is ready to donate. So that is electron rich species. Electron rich chemical species is called nucleophile. Then what is ambident? So the nucleophile which is able to attack by 2 or more nucleophilic centers is called ambident nucleophile. For example, if you take cyanide, CN, means this carbon may attack and a nitrogen also may attack. Means what this nucleophile is containing 2 nucleophilic centers, right, or 2 nucleophilic sites. That type of nucleophile is called ambident nucleophile. So let's go to that. The nucleophile, because we are discussing that ambident nucleophile, the nucleophile which is able to attack, by 2 nucleophilic sites or centers, you can say 2 nucleophilic sites. It may contain 2 or more also, right, but minimum 2 nucleophilic sites. The nucleophile which is able to attack by 2 nucleophilic sites is called ambident nucleophile. That's it, very simple. They will ask you that define ambident nucleophile. So the nucleophile which is able to attack by 2 or more nucleophilic sites is called ambident nucleophile. Very simple. You may write the example simply. Example is Cn minus. It means what here? N is containing more number of electrons. You may write Nc minus. Cyanide or isocyanide. So you may write just Cn minus also. No need to write Nc minus also. Cn minus is example for ambident nucleophile. One of the example for ambident nucleophile. If you take alkyl group, any alkyl group, it may give R bond Cn, alkyl cyanide. It may give R bond Nc, alkyl isocyanide. Very simple, right? Alkyl cyanide or alkyl isocyanide, anything it can give. So simply you can say that cyanide. You may write that cyanide. Cn minus. Okay. The next one, the second one, they may ask you that enantiomers. They may ask you simply that define enantiomers. So enantiomers means stereoisomers. Stereoisomers which are related as, both of them each other related as non-superimposable mirror images. For example, this hand and this hand, both were doing like this. So what here? Each one is just having on the another hand. One hand is having, another hand, all the bonds are attacking with each other. Both of them are having same. This is called superimposable. Thumb, thumb, index, index, middle finger, middle finger. Like that, all of them are having. So this is called superimposable mirror images. When you have taken like this, right? Thumb is here, another thumb is here. Both of them are here. This is called non-superimposable mirror images. So the stereoisomers which are related as non-superimposable mirror images to each other is called enantiomers. Simple. So we can say that the which are related each other, which are related with each other. So both of them are relating with each other as, I said one word that is very, very important. Non-superimposable. Non-superimposable. Imposable mirror images. Mirror images. Right? The stereoisomers which are related with each other as non-superimposable mirror images are called enantiomers. Enantiomers. Right? Very simple, right? Enantiomers. The stereoisomers which are related with each other as non-superimposable mirror images. Those are called as enantiomers. So, example for this, we are having butanol, for example, 2-butanol. 2-butanol. Here, 2-butanols are having two stereoisomers. One is rotating clockwise, another one is rotating anti-clockwise. Which are rotating clockwise is mentioned with plus sign. Another one is mentioned with minus. Both of them are combinedly having here that plus 2-butanol, right? Minus and minus 2-butanol. 2-butanol. So this is the example for enantiomers, non-superimposable mirror images, right? So next one, the third important one is racemic mixture. Racemic mixture. So this is one mixture. Mixture of what is called racemic mixture? That is the point. So the optically active mixture of two enantiomers. The optically active mixture of two enantiomers is called racemic mixture. The optically active. So you can say that the inactive mixture, not active mixture. The optically inactive mixture, which is, I will tell what is optically active, optically inactive. Which is the optically inactive mixture which is formed by the combination of two enantiomers. Two enantiomers is called racemic mixture. Racemic mixture means both of them are combined. Two enantiomers are combining. That is called racemic mixture. That mixture is called racemic mixture. right? So we wrote in the enantiomer example is what, plus 2-butanol minus 2-butanol. Now we are writing plus minus both of them combinedly. That is example for racemic mixture, both of them. So here I told you that one is having clockwise rotation, another one is having anti-clockwise rotation. Now we are saying the mixture, right? So one is rotating clockwise, another one is rotating anti-clockwise. So because of that, what will happen? Both will get cancelled. So rotation is 0, right? So that is called optically inactive. When the rotation is not there in the polarimeter, that is called as optically inactive compound. So this is racemic mixture is example for optically inactive. So example you can write plus minus, both of them I'm writing here, 2-butanol, that's it, 2-butanol. This is the example for racemic mixture. So this is one of the important question for 2 marks. And finally, one more question. Fourth question I am writing here. Fourth one, they will ask you that retention of configuration. Retention of configuration. So retention of configuration means there is no change in the configuration. Very simple. There is no change in the configuration means that is called retention of configuration. For example, this is one reactant, for example. This is one reactant. So this blue one is now at right side for me, right? Linking with right side. Here one chlorine is there. When it is undergoing nucleophilic substitution, what will happen? This bond will not change. Here I told chloride that will replaced by OH. Bond is bond, nothing will happen. There is no change at all. This is called retention configuration. For example, I will tell opposite, you will get most. Now this is at left side, right? Same thing, but this is at left side for me left side. So here also same, bond is bond, but bond shifted to right, from right to left. Cl replaced by OH, of course. This is called inversion configuration. So retention of configuration means there is no change in the configuration. So we can define that like this. The preservation means there is no change. The preservation of integrity of spatial arrangement of bonds around a symmetrical carbon is known as retention of configuration. Retention means there is no change. Retention of configuration. Very simple. Retention of configuration means whatever the bonds we have reactant side, there is no change in the bonds, right? That preserved that all bonds are preserved means there is no change. Example, I am taking like this: hydrogen, here Cl. For example, this is somewhat thick bond. This one is dotted bond, right? CH3Cl, methyl chloride. So here Cl minus will be removed. And what is coming here? Nucleophile is coming. Nucleophile is attacking, which is having more number of electrons. Nucleophile is coming. Cl minus we are removing. And this OH minus is attacking here. So there is no change. All the bonds are same as it is. How they are? Whatever they are, I am writing like this. Okay, same. Here what? Hydrogen, no change. Here what? Dotted line, hydrogen, no change. Here normal line, hydrogen. What is the change here? OH will come like this. So here Cl at which side? Left or right? Right side. OH also what? Right side, right side, right side. Correct? So there is no change in the spatial arrangement of bonds. So this configuration is called retention of configuration, right? Retention of configuration. So these are the four 2 marks questions. They may ask you that define ambident nucleophile, or define enantiomers, or define racemic mixture, or define retention of configuration. They may ask you any two for 4 marks. Each one carries 2 marks, right? So that's about very short answers. Now we'll go for short answers questions. There are only 2 important questions for short answers also. I think everybody know them. Try to understand them, how we are writing simply to get 4 marks, right? So the first question is, explain SN1, SN2 reactions. That is the question. The question is, explain SN1 and SN2 reactions. SN1 and SN2 reactions. Explain SN1 and SN2 reactions. Means we have to write that what is SN1 reaction and what is SN2 reactions. Like differences you can write like a table. What is SN1, what is SN2, right? So we'll try to differentiate both of them. SN1. Here what? 1 means unimolecular. Unimolecular nucleophilic. Unimolecular nucleophilic. S for substitution. Substitution reaction. That is the meaning of SN1 reaction, means unimolecular nucleophilic substitution reaction. So what about SN2? You can say this. SN2 means in the place of uni will get bimolecular. That is the only difference, because 2 bimolecular nucleophilic substitution reaction. This is called SN2 reaction. Bimolecular nucleophilic substitution reaction. SN1 reaction, SN2 reaction. So here the differences you can write simply. This is SN1 unimolecular nucleophilic substitution reaction. This is SN2 bimolecular nucleophilic substitution reaction. So the first point is here that it follows first order kinetics. First order kinetics. Simply we can remember that here SN1 means 1 is there, so first order. SN2 means what? Second order. So first order kinetics. Why? Because rate is directly proportional to only alkyl halide, concentration of alkyl halide. That is why this is, you can say that it follows first order kinetics. Here you can write oppositely that it follows, it means SN2 here, it follows second order kinetics. So what is the meaning of that? Again, second order kinetics means rate. In the first order, what? Rate is only depending upon the alkyl halide, not nucleophile. But in the SN2 reaction, both of them. So you can say that rate is directly proportional to concentration of alkyl halide as well as concentration of nucleophile. Nu minus means nucleophile. So two concentration of alkyl halide and nucleophile. That is why second order kinetics. Here concentration of only alkyl halide. So first order kinetics. Correct? So here it follows first order kinetics, it follows second order kinetics. The next one is here that this reaction completes in 2 steps. This is important. In SN1 reaction is completed in 2 steps. What about this? This reaction completes This reaction completes in here 2. That is why here only single step. In single step. Single step. SN1 means 2 steps. SN2 means 1 step. Single step. Right? So, next difference is here. The product has retention configuration. The product has retention of configuration. Already we discussed that what is retention of configuration. So in the SN1 there is no change in the configuration. That is why that is called as retention of configuration. We can say here what? The product, opposite to that, the product has inversion of configuration. Inversion of configuration. That is containing retention of configuration. This is containing retention of configuration, right? The next one, next difference, that it contains, or you can say that it forms product, it forms product through an intermediate. So this is the stable carbocation is intermediate here. We will discuss when we are writing the example for this, right? It forms, or it forms product. So here also product is formed, there also product is formed, but how that is forming, that is the point. It forms product through their intermediate, right? Through transition state. That's it, very simple. I will tell you what is the transition state also. Okay, and one more important point is here. The order of alkyl halides. The order of alkyl halides as follows. So how is it? As follows. Tertiary is greater than, secondary is greater than primary. So in the SN1 reaction, tertiary are more reactive alkyl halides are tertiary in SN1. In SN2, we can say that primary, right? So we can say that the order of alkyl halides in which reaction? SN2 reaction. Alkyl halides as follows. So how is that? You have to check that. Opposite to that, primary is greater than, secondary is greater than tertiary, right? Primary is greater than, secondary is greater than tertiary. So for both of them, each one example you have to give, then the question, the answer will be completed, right? So for SN1 and SN2 reactions, we have to give examples. Each one example we have to give. That here example, here which one is more reactive means tertiary, right? So we have to take tertiary alkyl halide. So CH3 thrice carbon is with bromine. It gives CH3 thrice carbon OH. So alkyl halide is exchanging into alcohol. So here bromine is eliminated. And what we are adding here? OH minus. This is tertiary alkyl halide. Here example you can say that primary alkyl halide you have to take. Primary alkyl halide. CH3Br methyl bromide. It will give what? CH3OH methanol. This is primary. Here also same thing. What we are removing here? All halide we are removing, Br minus. And what we are adding here? OH minus. Nucleophile is attacking here. So these are the things you should write when they are asking that explain SN1, SN2 reactions. So they may ask you that how can you differentiate SN1, SN2 reactions also? You should write the same answer like this. Okay. Now, finally, the last one, explain SN2 reaction, only SN2 reaction. Explain SN2 reaction with suitable mechanism. That is the question. Explain SN2 reactions. Explain with example, you can say. With example. Explain with example SN2 reaction and mechanism. Mechanism. So this is one more important question. Very, very important. So why did I not rub this means? This answer as it is you should write like this for this. But we have to extra what we have to write is instead of this SN1 reaction, we have to take this example and we have to explain the mechanism for this. Right? Very simple that. Whatever you have taken here example, that only we will take. So here CH3 Br is reacting with what? Nucleophile. And it is giving what? CH3OH plus Br minus. So now rate is depending upon here SN2 means what? Both alkyl halide nucleophile. So you can say that rate is directly proportional to alkyl halide is what here? CH3Br, concentration of CH3Br as well as concentration of OH minus. Correct? Now we'll discuss the mechanism. So here CH3Br we have taken CH3. So here hydrogen with the thick line I am taking here CH3. This is one hydrogen. Whatever I wrote there CH3 only I am writing CH3 CH. One more is here dotted line, one more hydrogen, and one more thing, you know that what is that? Hydrogen normal line. What is that halide here? Br minus. Br minus. Br. This is Br, bromide. Okay, CH3Br. Methyl bromide only I have taken. So here, this like this. This structure we have to remember how we are writing, that is very, very important. Now here, SN2 reaction, what will happen? SN2 reaction forms product through the transition state. Correct? So here, attack of nucleophile first we will discuss. Attack of nucleophile. This is the OH minus. Br minus also one nucleophile. Correct? So here Br minus also one nucleophile. OH minus also one nucleophile. Already one nucleophile is there. It can't move through front. So it will go from the behind of this molecule like this. This hydrogen is not there. The dotted line means what? That is backside of that carbon. Behind the carbon it is there. So it is have one good way to attack like this. Okay, I will show that with arrow mark. This OH minus will attack like this. Right now what will happen? Whenever it is coming like that, these bonds will change their places. So carbon, this hydrogen, because of this OH minus, this hydrogen will come like this. This is the hydrogen. Okay. And here hydrogen, one more dotted hydrogen will come like this. This is the dotted hydrogen. This is the normal hydrogen. Okay. And what is coming here? This OH minus is attacking OH. Here what will happen? This Br is leaving. So here this carbon is having that OH is attacking from this, Br is leaving. Simultaneously both of them happening here. So this state is called transition state. Transition state. This will happen slowly. Of course, one step only. After that, it will become fast. So fastly, what will happen? This you have to observe again carefully. Very, very important. Carbon is at center. Observe that hydrogen. this hydrogen will come like this. Hydrogen. We know that what we are writing here, the product has inversion configuration. That is very, very important. Now observe that inversion, how it is coming. And this hydrogen will come like this, and this hydrogen will come like this. And that Br minus, instead of Br minus, what will come here? OH will come. OH, this is the product. Plus remaining product is what? Br minus. Br minus. Here OH. If you observe that this configuration, here Br is at right side. Here OH is at left side. So this is called what? Inversion configuration. Right has become left, or left has become right. Okay. Here we have to write the 2 points about the mechanism. In that, first point is what? The configuration of carbon. The configuration of carbon atom. Carbon atom in above mechanism. In above mechanism. Attack under nucleophile. Under nucleophile. Attack under nucleophile. Arranges in such a way that as umbrella, try to understand this, umbrella turns inside out. Umbrella turns inside out when caught in a strong wind. Everybody has faced it, I think. Strong wind. Whenever in the rainy season, when you go out by using umbrella, what will happen when the strong wind has come means, the umbrella turns inside out, right? Whatever they are here, right? It will be when the strong wind will come means this will become like this. If you observe this, here all the three are like this, correct? So whenever product has come means what? That will become like this. So this is the point. The configuration of carbon atom in above mechanism attack under nucleophile arranges in such a way that an umbrella turns inside out, reverse. So inversion configuration. That is the one point. One more point we will write and we can close this, right? The second point and last point about transition state. In transition state, this is what? OH minus. This is what? Br minus. Means what? This is called incoming group. This is called leaving group. Both of them are bonding simultaneously. That is called transition state, right? In transition state, leaving group in transition state, leaving group and incoming group bonded carbon atom simultaneously. So when you are writing this, you will get 4 marks. That's it. So whenever you are you learned that differentiation of SN1 and SN2 reaction, that SN2 reaction as it is you have to write whatever the points we discussed in the before answer, and extra we have to add this example, right? This example and mechanism, this is called mechanism. This is called mechanism. And these 2 points are what? These 2 points we explained about the mechanism, about the transition state 1 point, and about this reverse inversion configuration, inside out, turning inside out umbrella. That point you should write. Then you will get 4 marks. So these are the damn sure questions in haloalkenes and haloarenes. Very, very, very important. Try to understand and try to learn them. Thank you. Bye bye.